Okay, everybody. In this video, I'm just going to go over how to simplify square roots, just the simple skill of simplifying square roots. There's nothing really understanding wise going on here, no big ideas, just a skill we have to be able to do. So to do this, you're going to probably want a calculator. I've got mine hidden right off the screen here so I can drag it in when I need it, just so you know kind of what's going on there. So when I need that, I will show you what I'm doing on the calculator right there. I'm going to go ahead and show you one way of doing this. If this way is just absolutely not making sense to you at all, I can show you other ways, right? There's lots of ways to kind of think about this. It is a skill. As long as we get the simplified version out the other end, it really doesn't matter how we do it. So we did a few of these. The first two, I'm going to pick ones that we did in class. And if you remember, the whole process here is just to simplify that number, factor that number under the square root as much as possible. And it really doesn't matter how you do it. So if I look at 24, maybe I say, well, that's 6 times 4. And then each of those numbers can continue to be factored. So 6 is 2 times 3. I don't know why I'm drawing the arrows on the end. That's kind of silly. And 4 is 2 times 2. Now, at this point, all of those numbers at the bottom are what we call prime. They cannot be factored anymore. And at this point, I'm just looking for pairs. If I have a pair, right, if I look at this 2 and 2, that means that there are 2 factors of 2 under my square root. And since a square root is just saying, well, what times itself makes a number, 2 times 2 is going to be a perfect square. That 2 is the one that I'm allowed to pull out to the front. And so I'd have the 2 out to the front. When I take the square root of that, I'm only getting 2, right? And then 2 and 3 do not have pairs, so they have to stay underneath my square root. And I do need to multiply those back together. And so I'd have 2 times the square root of 6 as my final answer. So the ones that are pairs, we're taking the square root of that. Think of this as 2 times 2 is 4, and the square root of 4 is 2. That's why we're only bringing one. It looks like we're only bringing one of those pairs out. It's actually because we are taking the square root of that number. Now, if we have a bigger number, this is where we probably are going to want to pull in our calculator. I have no idea what makes 108. I do know one right off the top of my head that I can, since it's an even number, I can do 2. But maybe you don't know, like, well, what's 108 divided by 2? I don't even know that. So we can grab a calculator just to help us out. Oops. So I can do 108 divided by 2. My calculator says 54. So I can say, okay, well, 2 and 54. Now maybe 54 is also a nice even number, so I could factor out another 2. If you see a number that ends with an even number, this is a good time just to say, okay, well, I know I can divide even numbers by 2 every time, so I get 27. So I can split that up as 2 and 27. Now at this point, hopefully you're realizing 27 is just 3 times 9, and 9 is 3 times 3. So now we've got this factored out the whole way. Are there easier ways, shorter ways you could have factored that? Probably. But it really doesn't matter how we get to this point as long as we get to this point. For our purposes, you are going to see a whole lot of 2s and 3s. You'll also see some 5s, some 7s, some 11s maybe. Probably not 11s that many. But those prime numbers are what you're looking for. So I see a pair of 2s. I see a pair of 3s. So what that tells me is outside my square root, I've got a 2 and a 3. 2 times 3. The only number that doesn't have a pair is that 3, so it stays under the square root. And then I just have to simplify. 2 times 3 is 6 times the square root of 3, and we are done. Okay, we'll go ahead and do one more. Square root of 30. Hopefully on this one you can look at this and you can say, okay, well, 30 is just 3 times 10, and 10 is just 2 times 5, and that's it. That's all I can do. So that's too bad. I guess we can't simplify that one because there are no pairs. There's nothing in 30 that is a perfect square. So I just have to leave it. The square root of 30. Can't do anything with that at all. That's okay. You will definitely have problems like that. You might even have some problems where you can't even factor them at all. And if I asked you for the square root of 13, you can't do anything with the square root of 13 because you can't even factor 13. That's one special case. Like that might happen. You might not be able to simplify. Let's look at another special case here. I'm going to get rid of this one. Something like the square root of 36. Some of you might look at that and know, without doing any work, that the square root of 36 is 6. And if you do know that, that is great. It's 6. Nothing's going to change that fact. Now, if you did not recognize that fact, you can still go through this process. I can say, well, 36, I know that's even. So that's going to be 2 times something. I'll pull my calculator over and take 36 divided by 2 and see that it's 18. So I'll have 2 times 18. I know 18 is 2 times 9. And I know that 9 is 3 times 3. And the big thing you'll notice with this one here is they're only pairs. There's 2 and 2, there's 3 and 3. There's no numbers left over, which means there's no numbers under my square root. A square root just doesn't exist anymore. Outside of the square root, I have a 2 and I have a 3, and 2 times 3 is in fact 6, but there's no numbers under the square root. 36 is a perfect square. We can't do anything with that one. Then we'll go ahead and take a look at this last one here. Just as a one more kind of, this is how you're going to do with most of them, though most of them are going to be able to be simplified, but they're not perfect squares. So 72. I'm looking at 72. Maybe you recognize that 72 is 8 times 9. If you recognize that, that is great. Otherwise, hopefully you'd recognize that 72 is at least even and you could divide it by 2. From there, I can go and split up the 8. I know 8 is 2 times 4. I know 9 is 3 times 3. And my 4 is 2 times 2. So now at the ends here, I've got all the prime numbers, 2, 2, 2, 3, and 3. I'm going to circle my pairs. There's a pair of 2s, a pair of 3s. But then there's this 2 just hanging out by itself at the end here. So that means that under my square root, I still have a 2. Outside, I'm going to have a 2 and a 3, which means I have 6 times the square root of 2. So that is one way to simplify perfect squares. The really nice thing there is it's pretty straightforward in how you do it. You just start factoring the number any way you know how, as long as you don't make a mistake and say, oh, well, 72 is really 7 times 10. It's not. If you did that, that would cause a problem. But as long as you factor it correctly, look for those pairs, and just remember, of each pair, one of them gets to come out, because that's the perfect square. This 3 times 3 is really 9, and the square root of 9 is 3. That's why it's on the outside. Okay, that is it. Hopefully you watch this video and we're able to do that now.